purpose of this video is for you to be able to account for how atoms are able to emit light. Before we go on, I just want to go over a few terms. To emit means to give off, like I'm emitting sound right now, I'm emitting heat, I'm emitting breath, and I'm also taking in breath. And then a spectrum is a broad continuous array of something where there are many different values, but they're all linked to each other. The rainbow is like a spectrum. It's all the different colors, and there's continuous from one end to the other. You can think of feelings are a spectrum from love to hate. Ground state is when you've got electrons in an atom and they're in the lowest orbital or orbital of lowest energy. So it's when the electrons occupy orbitals of lowest energy.
Good afternoon, Mr. Andrade will be.
Now, an orbital is a place to find the electrons around the nucleus, a place to find them. Sometimes they're spherical, sometimes they're not, but it's simply a place to find them. In Bohr theory, the orbitals are represented with the rings, all right? Like rings around the nucleus, where you're going to find them. That's what an orbital is called, or what an orbital is. The excited state is when your electrons are not in the orbitals of lowest energy. For some reason, they've got excited and they moved up. So excited state is when electrons absorb energy, move higher to a higher energy orbital, and there's some lower energy orbitals that are unoccupied. So electrons absorb energy, they're occupying higher energy orbitals, some lower energy orbitals are unoccupied. Now, an emission spectrum is the light that's given off by an object or a thing. And it's emission spectrum. Now, the reason it says emission is because it's giving it off. And the reason it says a spectrum is because it could be anywhere within a range of values. Now we get to what's happening in an atom to figure out how this is going to come about. How does it produce light? You've got hydrogen, and hydrogen, we're going to use hydrogen because it's the simplest case. It's easy to understand. It's got one electron. You've got a nucleus, and you've got an energy level here. And you've got an electron in that orbital on the first energy level. It's whizzing around, chilling out. This would be its ground state. Now, in its ground state, hydrogen and every other element has other energy levels that are unoccupied, vacant rooms in a big house that go above it, all right? Now, I'm going to erase a couple things. I'm going to erase this. I'm going to erase that. I'm going to erase that. Now, here is an unoccupied second energy level. There's my electron, and there's that energy level right there above it that's vacant, unoccupied. And there's other ones. There's the third energy level, there's the fourth, all the way up to infinitum. Don't know if I said it right. Now, what might happen, and what does happen, is something gives this electron energy. We are most commonly see it as electricity. Sorry. I'm distracting like doing this because I can see myself. Anyways, electricity comes in and hits the electron. The electron absorbs the energy, much like you absorb the energy out of a Snickers bar. And hops up here. The electron moved from this orbital to this by absorbing energy, electricity. This is called the excited state, all right? It got the energy and it moved up. Now, while it's in this excited state, eventually it's going to want to chill out and go back to chilling out. So it's going to drop back down. It's going to jump back and release a photon. And a photon is simply light. Typically, it's in the visible light spectrum, and we can see it. Now, you could compare this to a ladder. The ladder represents like where the electrons are. It's like the electron cloud. So the ladder is the electron cloud. That's what it is. It represents where the orbitals are. The rungs represent the energy levels or orbitals, where you're going to find the electrons. To move up is going to require energy. That takes energy. To move down releases energy. Therefore, being on the bottom on the rung, the ground is the nucleus, and the up here is where you'd find the electrons. So the move away from the nucleus takes energy. It takes a lot of, just like moving up a ladder. And if you think of electrons moving rung to rung, it's going to take energy to go from one to the other, to hop really. And when they go back, they're going to release that energy. And you could liken it to like the amount of energy when you jump off a top of a ladder, when you hit the ground, you jump from higher up and come back to the ground, you're gonna impact more energy on the ground itself. So just to go over that, a ladder analogy. The ground is the nucleus, the ladder is the electron cloud, the rungs are the orbitals or the energy levels. To move up takes energy, just like it requires energy to move a ladder, up on a ladder. To move down, you release energy. And the gravity in this scenario is what's representing the attraction between the nucleus and the electrons, making it all work.